Good day, everyone. Our topic for today is to describe the structure and evolution of ocean basins. The questions such as what is ocean basin, how to describe the structure of ocean basins, and how did ocean basins evolve are the questions that can be answered through our discussion. Seafloor spreading and subduction are the most important types of tectonic activity that shapes ocean basins. Now let us find out what are ocean basins. Ocean basins are a consequence of plate motion. Subducting slabs pull on their plates, leading to spreading at divergent plate boundaries. The ocean basins are partially bounded by continents, but they are interconnected, which is why marine scientists referred to a single world ocean. There are five major ocean basins coordinating the major oceans of the world. These are the Pacific Basin, Atlantic Basin, Indian Basin, Arctic Basin, and the Southern Basin. Many smaller basins are often considered as ocean basins, such as North Aleutian Basin. It is between the Pacific and Arctic Ocean. The structure of ocean basins involves measuring the size and shape of the Earth's ocean basins. The continental margins of major features of the ocean floor are continental shelf with less than 150 meters of water depth, continental slope with 1,200 meters water depth, and the continental rise is found at the base of the continental slope. Ocean trenches are long, narrow, steep-sided depressions found on the ocean floor that contains the greatest depths in the ocean. Ocean trenches mark the transition between continents and ocean basins, while ocean rises includes seamounts such as guyos, atolls, and all forms of submarine volcanoes and submarine plateaus. Those types of margins may be passive, whose shelves hundreds of kilometers wide, or active, whose shelves less than 1 kilometer wide. Ocean basins can be active, with a lot of new structures being created and shaped, or inactive, where their surface is slow to change and does little more than collect sediment. Mid-ocean ridge is normally found rising above the ocean floor, at the center of the ocean basins. Mid-ocean ridges are long littoral mountain chains which occur in all oceans and down basins. Deep ocean basins greater than 4,000 meters in water depth. It is typically flat or subdued topography. Now let us find out how did ocean basins evolve. Different ocean basins are distinct based on their stage of geological evolution. According to the Wilson cycle, the stages of ocean basins evolution includes embryonic, juvenile, mature, declining, terminal, and relict scar. The stage 1 is embryonic, where continental rifting plays a key role in the formation of an ocean. New basin will become part of the eventual continental shelf slope rise zone. The example of this is the Great Rift Valley in eastern Africa. The stage 2 is juvenile, where seafloor basalts begin forming as continental sections diverge. It is fairly shallow if repeated influxes of seawater become partly evaporated. Salt deposits will accumulate. The example of this is the Red Sea. The third stage is called mature. Becomes broad as it widens and trenches will develop and subduction begins. The ocean floor between the spreading axis and the continents of the sites by thermal contractions of the underlying lithosphere, abyssal plains form and the continental slope rise zone become fully developed. Stage 4 is declining, when subduction eliminates much of seafloor and oceanic ridge. The reason for the formation of new destructive margins probably lies in changes, circumstances in another part of the globe, such as continental collision or the initiation of new continental drifting and dominant motions are spreading and shrinking. The example of this is the Pacific Ocean. The fifth stage is called terminal. The last of the seafloor is eliminated and continents collide, forming a continental mountain chain. And the last one is the relic scar, which involves uplifting and shrinking of the young mountains. The structure of ocean basins and stages of their evolution give us the idea that ocean basins made up more than 70% of the total land on currents. According to researchers, the Atlantic Basin has been the most active area of oceanic crust creation over past 200 million years.